Hi everyone, this is section 9.3, problem number 19. We have 9x squared minus 16y equals 144. So the first thing it says to do is to solve for y in terms of x. So that's what we're going to do first. Let's see here. All right, we're going to take negative 16y squared, okay, is going to equal negative 9x squared plus 144. All right, we're going to divide everything by a negative 16. We're going to get y squared is equal to 9/16 x squared. It'll become positive because two negatives become positive, minus, and then 144 divided by negative 16 is going to be 9. So minus 9. All right, now this is a little bit of the tricky step right here because I am going to factor a 9/16 out of both of these terms right here. And when I factor a 9/16 squared out of this first term right here, okay, I'm left with x squared. And when I factor a 9/16 out of this term, I'm left with 16. Now that's a little confusing, but distribute the 9/16, okay? Think about it, 9/16. Let's just go backwards for a minute, just so you see that I haven't done anything I shouldn't have done, okay? Look, I'm going to get 9/16 x squared, see? No problem there. And then 9/16 times negative 16 is 9 because the 16s will cancel, right? So when I distribute the 9/16 to this term, again, I'll get 9/16 times 16. 16s will cancel, and that will be 9. All right, so hopefully that makes sense to you, and I didn't throw anybody off doing that. Okay, so that's what y squared equals, and so now we're going to take the square root, and we're going to get positive negative square root of 9/16 is 3/4, and the square root of x squared minus 16 is x squared minus 16. Nothing really I can do with that. All right, and let's do the squishy thing because that's A. A is done. A is done. All right, now B says, what's going to be a problem? X, see, the problem here is if x is anything, I think x, the only thing that's going to work, x has to be something between -4 and 4. If I pick a number larger than 4, like let's say 5, okay, let's pick 5, then look, I'm going to get y equals positive negative 3/4, okay, radical 5, right? I'm letting x equal 5. So let's say that over here, x equals 5. Okay, if x equals 5, y is going to equal positive 3/4, 5 squared minus 16, right? 25 minus 16. So y is going to equal positive negative, whatever this is. But, you know, do you see the problem? No, that's not a problem. Is this a problem? 25 minus 16? I can do that. X is 5. It's okay. Oh, that's not a problem. This is where, okay, wait a minute. Yeah, I'm okay. X can be anything. I think I read the problem wrong. X can be anything less than -4. This is okay. That's okay. And x can be anything greater than 4. The problem is, what if I let x be 3? So let's let x be 3 and show you that we have a problem there. If x is 3, see what this is what's going to happen. Y is going to equal positive negative 3/4. And then see the problem is I'm going to get radical, and if x is 3, I'm going to get 9 minus 16. Do you see the problem? See the problem? I'm going to get, you know, a negative under the radical. I'm going to get an imaginary number. 9 minus 16, whatever that is. It's -7 or so. So, you know, no, ain't going to work. You know, so the problem here, so these values right here where we have -4 is less than x less than 4, there are no real values in this range. No real values. They'll all be imaginary values in that range. So hopefully that made sense. All right, that's B. Now let's move on. Let's look at C. What does C say to do? Explain why there will be 2 values of y for each value of x. Well, let me just, that's pretty straightforward, right? There's going to be 2 values of y for every x because look at, it's the positive and negative. There's going to be a positive value, there's going to be a negative value. So there will be 2 values. So we can say here, because of the positive, negative signs. Okay, So let's look at D now. Let's see what's going on with D. Make a table of values and so let's do that over here. Can I do that over here? Or maybe I should do that here. I don't know. Let's see, X, Y. Can we make a table of values from, it says from where? Make a table of values from 4 to 8. 4 to 8. Okay, so 4, 5, 6, 7, 8. Okay, so we're just going to put those in, and when I do that in a calculator, when X is 4, I think I'm going to get Y is 0. Y is 0, because I'll get 16 minus 16, I'll get 0 there, not, so 0, right? When X is 5, I'm going to get, rounding it off, I'm going to get 2.25. Okay, when X is 6, I'll get, you know, and I mean, you see how to do this, right? If it's not very hard, you just put 6 into the for the y equals, and so I'm going to take 3/4, which is 0.75 times, whoops, and I better say positive negative here, right? It's when X is 5, Y could be positive 2.25 or negative 2.25. When it's 6, I'm going to take 0.75 times, and then I'm going to put in parentheses 36 minus 16, 36 minus 16, and then I'm going to raise that to the 0.5. So hopefully that makes sense what I put into the calculator, and I'm getting 3.35. So positive, negative 3.35. All right, for 7, I'm going to do the same thing. I'm going to say 0.75, that's the 3/4, times, and then in parentheses, or I don't even have to put the times, I could just put parentheses next to it, right? 49 minus 16. Right? Oops, and I need to raise that. Okay, wait, let's try it again. 0.75 times, and then I'm going to take 49 minus 16, and I'm going to raise that to the 0.5. There we go. And I get positive negative 4.31. Positive negative 4.31. And then when it's 8, I'm going to get positive negative 5.20. All right, that's D. Now E, it says explain why you can use the same table of values of Y for values of X between -4 and -8. I mean, I could do the same thing, but if all I have to do for, just put a negative here, and it's exactly the same, right? Because, because of that X squared, right? So when I put -4 in, it isn't going to change the values. So really, this works for positive or -4, positive or -5 are going to give me the same values here too, because the opposite of X squared is still just X squared. So it's not going to change anything. All right, so that's it there. Let's see. E, plot a graph from -4 to -8 and from 4 to 8. So here we go. Let's plot our graph right here. We'll come over here. 1, 2, 3, 4, 5, 6, 7, 8. Right, and we'll come over here. 1, 2, 3, 5, 6, 7, 8. Maybe we'll go up to 9 just real quick. Okay, and then here 1, 2, 3, 4, 5, 6, and 1, 4, 5, 6, 7. Okay, so there we go. All right, when X is positive 4, Y is 0. 1, 2, 3, 4. Y is 0. No height. No height. When it's 5, it's going to be positive 2.25, or it's going to be negative 2.25. Okay. Now when it's 6, it's going to be positive 3.35, 3.35, just a little above the 3, and negative down over here. Look at that, pretty, huh? It's pretty. All right, when it's 7, it's 4.31. Let's see, 4, 1, 2, 3, 4.31. So it's just a little above the 4 again, and a little below negative 4.31. There we go. When it's 5, let's see, 1, 2, 3, 4, 5, 6, 7. When it's 8, it's 5.2, just a little above the 5, and just a little 1, 2, 3, 4, 5, just a little below the 5 right here. All right. Oops, that's not very good. Let's try to make this pretty. There we go. Woo! Nice. Look at that. Just so pretty. Pretty, 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 pretty. And let's see if we can do the other one over here. What is it? Positive, -4. So right here it's going to be 0. Right here at -4. And then we're going to come out here. It's 2.25. And 2.25. And then at 3, it's, you can see the same thing here. Right, and then at 4, I'm just kind of going a little too fast here, but 5, it's not 5, 4, 5, 6, 7, at 8, it's 5, 1, 2, 3, 4, 5, somewhere up over here. I didn't quite take that one up high enough. And then same thing down over here. All right, so I mean, it's the same thing over on this side. I didn't quite plot them because I got too fast there. All right, cool. Isn't that cool? Okay, and then the last thing it says to do on the same Cartesian coordinate system, plot graphs of the lines y equals 3/4 x. So here we go, y equals 3/4 x. Let's put some dots here. Y equals 3/4 x means the slope is 3/4. So it's going to be, if the slope is 3/4, notice by the way that's, let me redo that here. The slope is 3/4. So it's going to be, up 3, 1, 2, 3, rise over the run. 1, 2, 3, 4. Right here. It goes from there to there. Now watch, let's just put a line there because I only need to do 2 points to determine a line, right? So if I just do these 2 points, I should be good to go. This should be it. Look at that. That's the asymptote right there that it's going to hug. And then if I put a -3/4, 1, 2, 3, and over 1, 2, 3, 4 right here, there's the other asymptote. And 2 points determine a line. I hope I did this one. I should hug it. I did it. Yeah, it's close. This may be just a tiny tad, a little sloppy there, but that's not bad. All right, that's problem 19. Hopefully that helps you all. Anybody struggling with that's the hard way to plot a hyperbola. All right, take care.